Good morning, everyone. On behalf of Kongunadu College of Engineering and Technology, it is a great pleasure indeed for us to welcome you all to the second international conference on smart data intelligence. This conference brings together academia, researchers, business entrepreneurs, practitioners, and policymakers who are responsible for delivering sustainable and eco-friendly solutions through leveraging advanced information engineering and technology for competitive advantage and cost saving in the modern industrial sector as well as public and business sectors. I heartily welcome Dr. R. Asohan sir, Principal of Kongunadu College of Engineering and Technology, and extend to welcome our conference chair, Dr. J. Yogapriya ma'am, who has arranged this wonderful event. Welcome you, ma'am. I warmly welcome today's event eminent speaker, Dr. Shajulin Benedict sir, who has traveled from all over the country to share his knowledge and teach all the techniques for improving technical expertise. Welcome you, sir. We extend our welcome to all the head of the departments, faculties, and students who greatly helped in organizing this conference. Once again, we welcome all the participants, delegates, eminent speakers, and guests from all over the world to this international conference, ICSMDI 2023. Now, I invite Dr. J. Yogapriya ma'am, conference chair of this event, to present the conference report. Over to you, ma'am.
Yes, ma'am. Thank you. So good morning, one and all present here. Today we are organizing a third international conference on smart data intelligence, ICSMDI 2023. It is my honor and privilege to welcome you all for this conference. So this conference is one of the prominent conference organized by our college. So this conference on smart data intelligence is sponsored by IEEE Computer Society. I would like to thank IEEE Computer Society for sponsoring this conference. So the theme of this year's conference is data intelligence. Over the last decades, data-driven approaches and data mining play an important role in several business organizations and industries. So these data-driven operations have presented unique challenges and also opportunities. Our hope is that 2023 conference will be a showcase of artificial intelligence technologies and tools, so which could be used to address the challenges and opportunities in various data analytic or data management context. So nowadays, deep learning and machine learning plays a major role to analyze various data analytics in various real-time applications, right? So all of our papers for our conferences were submitted by people from all over the world. So total of 392 papers we have received it. Out of 392, we have accepted 100 papers for this conference. So this conference acceptance rate is less than 30%. So the subject experts from various reputed institutions and industries mentioned in the technical program and review committee reviewed all of the articles, have given and wonderful comments to all of the participants. So we strictly follow the standards and regulations of IEEE Computer Society publication. So at this juncture, on behalf of conference committee and technical program committee of the conference, I'm proud to say that so we will maintain the reputation and quality of the IEEE conference proceeding publications with IEEE Explorer. So we are happy to inform that 100 accepted manuscripts were submitted to IEEE CPS and the proceedings will be published within a month. I would like to express my heartfelt appreciation and gratitude to the management of our Kongunadu College of Engineering and Technology for taking the initiative to organize this event. And on behalf of the organizers, including the technical committee members of ICSMDI 2023, so consider it a privilege to have your blessings and good wishes on this event. So I extend a warm welcome to the keynote speaker, Dr.Shajulin Benedict sir, guest professor of TM Germany and faculty in charge R&D and International Affairs, Indian Institute of Information Technology, Kottayam, India, for your gracious presence in this event. So finally, we would like to extend a warm welcome to all the research scholars, professors, and authors of registered papers who will be presenting their work at this conference. So I wish you all the best of luck with this international conference, and I look forward to learning about the outcome. So thank you, one and all.
Thank you, ma'am. It is an honor for me to introduce our chief guest, Dr. Shajulin Benedict, sir, guest professor of TUM Germany and faculty in charge R&D and International Affairs, Indian Institute of Information Technology, Kottayam, India. He graduated in 2001 from Manoன்மணியம் Sundarnar University, India, with distinction. In 2004, he received ME degree in Digital Communication and Computer Networking from AKCE Anna University, Chennai. He is the university's second rank holder for his master's. He did his PhD degree in the area of grid scheduling under Anna University, Chennai. He was affiliated towards the same group and published more papers in international journals. After his PhD reward, he joined a research team in Germany to pursue postdoctorate under the guidance of Professor Jerndt. He served as professor at ASX Research Center of Anna University, Chennai. Later, he visited TUM Germany for teaching cloud computing as a guest professor of TUM Germany. Now, he works at the Indian Institute of Information Technology, Kottayam, Kerala, India, an institute of national importance of India. He serves as Director, PI, Representative Officer of AIC, IIT Kottayam for nourishing young entrepreneurs of India. His research interests include HPC, cloud, grid scheduling, performance analysis of parallel applications, cloud computing, IoT, blockchain, parallel compilers, and so forth. I'm honored and privileged to welcome our chief guest and keynote speaker, Dr. Shajulin Benedict, sir, to deliver the keynote address. Over to you, Professor.
Thank you, madam. Let me share the screen. So, yeah, it's also interesting and thankful for inviting me. Let me thank Dr. Ashogan sir, the principal, as well as Dr. Yogapriya madam, the chair of this conference. In the meantime, let me share the screen. I hope it's visible to you.
Yes, sir, it's visible.
Okay. So the conference ICSMDI 2023 is more interesting conference because of the topic, aligned topic, and a very futuristic domain too. So this keynote today, I will be talking about IoT communication protocols as well as social good applications that basically need a lot of data as well as intelligence should be performed there. So most of my talk will be more towards IoT, collecting data as well as the communication protocols that were there in IoT systems. So a very, very brief detail were already presented earlier. So this is how the agenda looks like. Like initially, I will talk about social good applications and how the data should be captured from there, and then the protocols, right? Like there are few communication protocols, and I will orient more towards 5G techniques as well as the trends that are more orienting towards 5G. And also a few research directions will be described. So in short, if you see social good applications, right, there are a large number of applications these days where we focus more towards the improvement of society. Right, like if you take cities, right, smart cities or cities, we develop applications that benefit people, right, benefit the society at a large. So such kind of diverse application that assists people and improve the welfare of people in a large community are termed as social good applications. Some of the examples, if you see, like forecasting, economic forecasting, like you want to see what would be the future economy in the country or in the society, or the applications that belong to personal assistance, like some automatic reminders that improve the productivity of people. um, think about applications like you most of you are researchers and you always have an intention to write articles, but at some point of time you are not getting, you often get diverted here and there. So if some IoT based solutions are there that could assist you, right, it could provide some hint that this is very important, this is the task that you have to be prioritized, right? So these kind of personal assistant applications that improve the welfare of society, welfare of people at large also, right? And some applications like language assistance, right? Like for example, you are traveling and you reach a place where you doesn't know languages, right? Foreign languages like German or Russian and so on. So if you have some applications that could automatically translate, right, and if it could give you some assistance in terms of language, or it is translating it and giving you in your own native language like Tamil, then it is improving your time as well as communication skills. People keep developing some applications, sensor and actuator based applications, and there are few applications that are already on market, but still the improvement or the development is always continuing in this language assistant domain too. Also speech recognitions, right? Recognizing things or some set of applications. You can also talk about transportation, smart transportations, right? Like mobility, smart mobility or shared mobility concepts are often very important these days, because the days where people started, especially in Europe, if you see, people started to reuse the public transportation because they are more energy carbon efficiency conscious people, and therefore they want to reduce the carbon emissions, so they stopped not stopped actually, but they are trying to from the government side, they are trying to reduce the utility of private vehicles, and they are pushing towards shared mobility and so on. So what kind of assistance in terms of IoT based systems are providing, right? That kind of solutions are becoming very popular in these days. Wildlife conservation as well as healthcare also is one of the very interesting application that improve the society. If you see the underlying technologies for all these social good applications, you can focus on developing some infrastructure, right? Infrastructure which could talk about how the learning could be carried out. How can you gather data? Do you need to process the data on edge or cloud or fog computing networks, right? So these kind of technologies are bundled, right? It is tied up with this particular application. In few applications, you could also see that blockchains are involved, and obviously MLDL, machine learning or deep learning kind of inferencing, as well as learning and training and testing kind of things are always there for improving the application capability. If you need to sense data, always we need to sense data. Without getting proper data, there is no point of learning, and therefore IoT, right, Internet of Things based sensing, is one of the key technology that drives such applications. Of course, you can avoid sometimes edge, you can avoid sometimes some other computing techniques and create some hierarchical structures, but sensors and connecting or sensing data through different means is obviously very important concern in all these applications. Let us see one generic architecture of social good application. You can, it could be something like this, right? If you see the sensors, right, for any social good applications are geographically distributed here and there, but there will be some kind of edge level processing, right? The reason why we need edge level processing, it's basically to process some some level of intelligence to filter some set of data that comes out of all these sensors. Typically in these days you will see like hundreds of sensors are always attached in one network, right? So before it is if before the data is allowed to reach some real our normal traditional network, it has to be connected through gateway, and it is not always good to transfer all data, right? So some intelligence, some filtering, some processing is needed at edge level. Therefore, a small computational part is always there, kept at edge, and for we do this kind of edge level intelligence, right? So there is also some other advantage with this edge, typically because for the entire social good application, even though you have spread the sensors in multi sites, the data from all the locations, when it travels through the internet, right, it can consume more bandwidth, right? The bandwidth can be very, very high. So we need to limit this bandwidth, or we need to efficiently utilize the bandwidth, network bandwidth as a whole for the application. So edge could save a large amount of bandwidth, because it is going to filter, or it is going trying to apply some intelligence at this level. Not only that, you are sometimes concerned about privacy, right? Think about applications like emotion experiments, right? Or that deals with the facial identity, and something that captures your face detail, or your voice data, your personal information, and so on. So that should be private, actually, even though the application surpasses from multiple networks to some cloud environment and makes some bigger processing at the cloud. We need to prevent such kind of data, private data, to reach the cloud, because we all know that cloud is a third party provider, right? So it is like a third party infrastructure. Of course, it is very less expensive. Therefore, people prefer cloud, and if you want to perform a very good intelligence, if you want to make a scalable training, and so on, obviously we need cloud. We cannot avoid cloud, but we cannot even send all data to cloud, because we are very cautious about the privacy involved in our applications, right? So a client or someone whose data should not get traveled or transported to cloud, or if he is concerned about privacy, then edge intelligence will be a better component here, right? So it can create a kind of parametric study, and only the some set of features that are really important for cloud will be transported to the cloud. Right. So this is how a generic social good application will look like. You can see like multiple infrastructures are involved, then sensors are involved. All the sensors from a particular site are connected through edge to some normal networks, which travels through that scalable network through cloud, and some bigger level processing happens at cloud. So cloud will have larger computation, and the edge will have very limited computation, and in between you can also have like fog or something which can even restrict or create some sort of data locality for your application, right? So this is a generic social good application. So in all these cases, if you see the sensors, right, all the sensors, whatever temperature or whatever sensors, right, camera sensors or whatever sensors, these all sensors should connect to edge or to cloud or to some network using some protocols. There are a few protocols, and there are a big list of protocols, but we will be focusing more towards 5G, 6G in this seminar. Um, in very short form, we all know that Internet of Things, it's like providing an internet to very small devices or things, right? So it is a kind of future internet. So millions of or trillions of sensors and objects will get internet, right? So currently we get internet only for laptops, mobile phones, but the things also should get internet, so that any objects could be detected, right? So in a social good application, especially for example air quality monitoring or water quality monitoring, it is going to suggest some improvements for the large mass of people, right? For the societal improvement, right? And so on. So the sensors will be spread across every places, and they are now going to communicate to you, right? Or as an agricultural farm, right? In this agricultural farm, you want to see whether the plant is growing very well, right? So you need to get the information from the sensors that are spread across. So they all get internet, and this internet, no, now it's like future internet. We have to detect them. So in very no brief, a sensor will connect through a network device, and there will be some actuator which will perform some action, right? If you take this social good application, you will also notice that sensors are there. Some no computation happens in the network, so they are all kind of network, including cloud. They are network, and then they are all networked devices, and then you perform some actions. Now some sort of action would be like, client will get a notification or someone else will get a notification, and what they have to do, they are all kind of notification. And accordingly, we can see like if the internet of things is applied in industries, we call it as industrial internet of things. If it is applied for personal improvements, or like for applying like wearable gadgets and so on, and making some personal improvements, so that the entire society is benefiting. When individual is benefiting, the entire society is benefiting, right? So that kind of application we can subdivide that as consumer internet of things. Social internet of things deals with social media related information, right? This kind of domain will sense information from social media sites, like you know Twitter, LinkedIn, and so on, and it will try to make sense out of that, and make the application more effective. Semantic is more tailored toward a particular person's social sites, or a person's wishes and characteristics. And prioritization is more like the sensors that are the IoT that is applied mostly towards towards the product, prototyping, like rapid prototyping using 3D printers and so on. So these are all subdomains of IoT. And if you talk about such a social good application, assuming that there are so many technologies, but Internet of Things, thinking about Internet of Things, you can imagine that this Internet of Things could be the sensors or whatever, the small things which are connected to the internet typically can have different communication protocols, right? Different communication protocols. 5G is one among that, right? So 5G, in a very brief, I will be explaining in detail in the later slides, but in a very brief sense, it is a next generation IoT system. Communication system, right, which uses 5G, right? 5G based IoT system. It is like cellular network, right? A mobile network, right? It is a mobile based communication network system. We are going to discuss different communication protocols that can be used in IoT systems, right? There are few platforms basically already having such kind of supports, right? Most importantly, like Amazon has offered AWS private 5G. Of course, licensing and stuff like that needs to be availed from government, but AWS also provides a small kit, okay? So a small kind of antenna structure that you can place it somewhere in your building, and all devices can get connected, as like your mobile phone, right? Mobile phone has SIM card. Similarly, this all the devices that are that needs to get connected using 5G will have such SIM cards, and they can make the connections, apply connections. So very importantly, what you want to understand is they are operated based on mobile networks. So you can create a private mobile network. So far, no, we are getting mobile through BSNL or Reliance or something, but now you can create your own mobile network, right? Private network, and then you can connect all the devices, right? So the devices, what we mean here is small machines, right? Maybe a fridge connected with a small device, and the SIM card will be there, and then that will also get internet, right? Or your mobile phone also becomes like a part of this 5G network. A small sensor network can get SIM card, and they can get connected to 5G network. Of course, it is not the only protocol, right? There are so many protocols, but I'm just going to talk about different protocols. Here I have listed a large list of sensors. So in general, we want to discuss social good applications. Of course, you understood what is social good application, and a very generic social good application architecture. There are so many technologies involved, like blockchain, AI, and so on, but we are focusing more towards IoT. In a very brief, we know what is IoT. What is IoT? It is a future internet, right? And we want to discuss the protocols, right? Communication protocols. Given one sensor, right? If a sensor is there, and if it needs to connect to some gateway or cloud, right? How it has to connect, right? How it has to connect. So there are so many protocols. One protocol is 5G, right? It is a wireless network-based system. We are going to discuss the tech. Of course, it is a technology, right? 5G mobile-based technology. We will have to discuss these different protocols, standards, and so on, which are used mainly for communications. That is, sensors connecting to gateway, or sensors connecting to some cloud network, or sensors connecting to edge network, edge device, right? So you can see a list of some protocol standards, technologies like 5G and so on. I will be giving a very brief explanation about all these protocols. IEEE not 2.15.4 is a standard, as like IEEE not 2.3 for Ethernet, and so on, right? Which you have learned in computer networks and so on. Like this, 802.15.4 is for personal area network. From the name, we can understand personal area network means it is it is a very, very it is the network designed for personal devices, right? Personal gadgets. So that's why personal area network, right? Local area network, wide area network, metropolitan area network. These are all some networks, but personal area network is mostly focusing on person, right? And this is the standard designed for such person, right? So person cannot get more, the devices should be very, very less harmful, first of all, and it should not have heavy wattage also, right? So the coverage may be very less, therefore, right? So it is typically having only 10-meter communication. And of course, for different countries, you have different bandwidth and restrictions and so on. But in general, it is supporting this ISM band, which is 2.4 gigahertz, which is very popular for developing your own devices based on IEEE 802.15.4, which restricts in many other standards. So if you talk about the devices, some devices are fully functional devices in IEEE 802.15.4, whereas some are reduced devices, which means fully functional devices will have the whole set of coordinator, personal area network coordinator, router, as well as devices that can attach the other devices, whereas reduced functional devices are devices where you cannot have all such routers and coordinators. So typically very small sensors that don't have its own computational power, especially like microcontroller based sensor nodes, right? So they cannot perform all sort of routing and coordination related things. So IEEE 802.15.4 has in the standard level itself, they have classified such devices into fully functional as well as reduced functional devices. So what is special here is this particular protocol is only for PAN, right? Personal area network, and it is only restricting to 10 meters, right? 10 meters. This is what we need to understand. So any device that are very near to you can get connected using this protocol if you want to design the device using such protocol. Zigbee is slightly different. Basically, it can provide mesh type of communication, and the device itself is very, very similar with one small antenna here. So with this, you can simply connect more number of IoT sensor nodes. It can simply get the mesh network, right? Once you plug in, immediately you get mesh network. It is basically following this IEEE 802.15.4 protocol only, but it is not following ISO OSI standard. Right, we know ISO OSI standard or TCP/IP standard. It has some standardized layers. But this Zigbee is not having such kind of standardized protocol, so layers. So because of this, it is not able to directly connect with to any network, right? Um, so there are some issues with this Zigbee protocol as such, even though it is able to quickly form the cluster of sensor nodes. So if you have hundreds of sensor nodes, you can simply use this. If it is following Zigbee protocol, it can simply connect and it can start transferring the data, right? But the device should follow the Zigbee protocol, and it has to follow Zigbee standard, right? Zigbee has its own protocol stack. which is not a normal standard as such, right? So because of this, it has limitations. It has a lot of limitations, and the idea why they brought such Zigbee by Zigbee Alliance is to reduce the power consumption or energy consumption of such tiny devices, because sensor nodes are very tiny. It has to be, they are operated on batteries, so the energy consumption is should be controlled or taken care, right? In ISO OSI standards or TCP/IP standard, it has a lot of layers and so on. It is the standard which you cannot avoid certain standards, and because of this, the energy consumption will be little higher. So to avoid that only, they tried this Zigbee protocol concept. But the problem here, you can see all these are similar, but what I want to show here is this part, right? So you can see application layer is there. Then you are having application support sublayer, then application network layer, and data link layer and physical layer. But if you see here, application layer, typically in our normal TCP/IP standard networks, you will have transport layer, right? There is no transport layer. They simply removed transport layer. So because they removed transport layer, you cannot simply connect any Zigbee device directly to networks, right? You cannot simply start collecting data, because if you want to perform data intelligence, you need data, and if you want to get data, right, in a perfect manner, it is not possible, right? So so because of this protocol stack, the idea why they brought this protocol stack is to reduce the energy consumption, because they are removing transport layer, and this application support sublayer is as part of this application only, right? So it is like conceptually it is as part of like application layer and so on. So some computations are reduced. That is the major concept here. But the problem is, it is not able to support the normal network. Although in future, recently they also have this Zigbee IP protocol, which is compatible with the normal TCP/IP standards. In the meantime, when Zigbee is there, they brought this 6LoWPAN, which is IPv6 based. So the idea of this protocol was to bring very less energy consumption concept, but with the same TCP/IP standard, with the same IP addressing standard, right? So 6LoWPAN became more popular, because even though Zigbee became almost very popular, the moment when they understood, competitors are there, right? So they started developing 6LoWPAN, which is based on IPv6 and the normal TCP/IP standards and so on, and the network was energy efficient too. So notably, this is also following IEEE 802.15.4 radios, right? These are all not mobile networks. No, you should understand this very carefully, right? So communication is not mobile network. Only 5G and so on are focusing on mobile networks. The all others are like our normal computer networking, like normal networks, not a mobile network concept. So 6LoWPAN and Zigbee had this, such kind of communication, and 6LoWPAN is became very popular, and it became very attractive one for many systems, right? So in the meantime, this of course there are so many other protocols like Bluetooth, RFID, NFC, and so on, where sensors could connect to gateway. All right, we are not going to discuss. Of course, it is one semester long course, to understand how to collect data from all these sensors, right? When their communication protocols differ, when their communication standards differ, right? So we are not going to discuss all the other protocols, but interestingly, it is also better to understand Wi-Fi. Wi-Fi, we all know, we are always using Wi-Fi, but these days, we have Wi-Fi 6. So Wi-Fi is falling under this IEEE 802.11 family, right? In 11 itself, there are so many variations: A, B, C, etc., D, G, and so on. And of course, whenever the standard varies, the data rate varies, then the support to some protocol stack varies, and so on. So standard, because they are standards, right? So in standards, they define how a device should be manufactured if you claim that it is having Wi-Fi, right? It also defines, if say for example, you are saying IEEE 802.15.4, then the device which you manufacture should follow that kind of protocol standard, right? This means the coverage, the coverage should be only 10 meters, right? The data rate should be this much. So that is defined in standards. And Wi-Fi is another communication protocol. Nowadays, many devices, right? Like for example, ESP, Arduino. Typically, Arduino, if you see, they don't have Wi-Fi by default, right? So you need to add one module, and then you will get Wi-Fi. So why we need such Wi-Fi? Because it is also one sort of communication protocol, right? To connect and send data from such sensor nodes to gateway, or to send the data to edge, or to send the data directly to the cloud. So you have different criteria, some different data rates, as you can see here, like 802.11, which operates with 2 megabit per second, right? But the very recent one, which you can see here, is Wi-Fi 6 and 6E. Okay, they are targeting high speed plus energy efficiency, okay, or power efficiency. Basically, they are wireless communication, right? And sensors, small sensor devices are also now getting Wi-Fi, right? Because think about ESP device, right? Expressive from China has produced a small microcontroller, which is also giving you Wi-Fi by default, or Node MCU, right? They are also giving you Wi-Fi, right? Inbuilt Wi-Fi is there. Inbuilt Bluetooth is there. Bluetooth is another standard, but they are having Bluetooth to collect the data and send it to gateway, right? But Wi-Fi 6 is targeting power efficiency or energy efficiency. We need to focus on energy efficiency because of sensors, right? The sensors should have energy efficiency. Otherwise, no, it will simply drain the power, and you cannot really realize a socially good application that will long last for a long period of time, right? So Wi-Fi 6 falls under 802.11.ax standard. Although it is released in 2019, it is yet to get adapted, right? In most of your organizations, you will only notice Wi-Fi, right? Wi-Fi 6 should not be there typically, right? But there are, if you are modernizing, right, then you will get the device, right, Wi-Fi device, which will follow the 6 Wi-Fi 6. So there is some difference if you talk about Wi-Fi 5 as well as Wi-Fi 6. See the difference, right? The data rate itself is 9.6 gigabit per second. This means you can simply download movie or directly do online gaming, and everything will be very fast. Technology-wise, orthogonal frequency division multiplexing, multiple user, multiple MIMO concept is there. Beamforming. This means you can the connected devices will communicate in the form of beams, right? So specifically to that device, you can send the beams directly towards that device, so that you avoid interference and reduce the energy, right? So that's the reason. These are all the reasons why you get very energy efficient system, right? And you also get the high data rate. But uh, ultimately, all these Wi-Fi 5 as well as Wi-Fi 6 are restricted with the number of connections, right? You can connect only if you take one Wi-Fi 6 or Wi-Fi 5 access points, right? You will notice that only limited number of devices could be connected. Similarly, LoRaWAN. LoRaWAN, from the name itself, you can understand it is wide area network. It is not local area network. Whereas wireless or Wi-Fi is providing you wireless LAN. But this communication protocol, LoRaWAN, provides you a long range wide area network, right? It is a wide area network. The name wide area network because it can connect a large number of sensors, and it can reach long distance, and typically it is reaching around 10 kilometers theoretically, but it will not reach 10 kilometer for sure, right? Theoretically it is reaching 10 kilometers, and in urban places it is told like it can reach like 1 kilometer to 5 kilometers, but on experiments what we did, it was reaching like 500 meters. Okay, that is the truth actually, but theoretical values show that it can reach 10 kilometers in rural areas, which means your line of sight as well as the of antenna and the receiver are having this line of sight, right? um, Problem with LoRaWAN is, it has a very limited bandwidth. Okay, you cannot send large video files, or even a small video file you could not send. Okay, you have to send only like one word, or very small data. Like for example, in an agricultural farm, you can have such LoRaWAN connected sensors, place them everywhere, right? 10 kilometers, right? So you can place them if your farm is like 5 kilometer area, you can place them here and there, and you just detect something, and then you will say, notice that yes, no, or you will say no, the temperature value is 33, 32. These kind of things you can send because of the principle behind this bandwidth as well as coverage, right? You can notice that the more the coverage, you cannot have higher bandwidth, right? But higher the bandwidth, right? If you have higher bandwidth, then you cannot have long coverage. So that is the formula actually, right? It is the physics which you cannot change. But the technology tries to solve these kind of things, right? So there are so many use cases which you can apply for uplifting your social or society. The most important protocol which technology which we are going to discuss is 5G. Okay, so what we have seen so far is social good application, and we are saying that IoT is one of the technology which is playing a major role, and there are so many sensors which needs to get connected, and for connecting such sensors there are several communication protocols. We have listed some set of communication protocols. Among all these communication protocols, no, we today are going to focus more towards 5G. Right, 5G is the trending one, and fundamentally it is not a normal wireless communication like our computer network communication, right? It is uh, networks, cellular networks. It is based on cellular networks like towers and so on, right? So that technology comes with different generations, like first generation, second generation, third generation, fourth generation. We all use them in our mobile devices, but nowadays, no, you can think of a lot of machines that are having such SIM cards, and they can also communicate each other. They can start sending streaming data and perform some intelligence at the edge level by creating a private 5G network, and you can run a big farm, or you can run a big uh, um, what do you call, like a plant or machinery, or by combining large number of 5G networks in a smart city, you can seamlessly provide very high speed communication and connections, because nowadays without mobile no one is living, right? You can make that as one of the sensing node, and because mobile device also has some lot of sensory, like mobile cameras are there and so on. So sensory things are there. uh, Beyond mobile phones, right? Mobile phones or smartphones, you have so many nowadays, like wrist watches and or some gadgets, right? Some gadgets that can also send information directly through mobile network, right? Mobile network, so which is fifth generation wireless communication. So it started, right? If you see in 2023, 5G started already, right? And it is taking momentum, which means you can start getting 5G SIM cards and so on in some places. Um, Licenses are provided in some places, right? Amazon is providing this, right? And you provided, if you have license, you get them. um, and You can order SIM cards, hundreds, thousands of SIM cards. There is no limitation in connecting devices, as like you can observe in Wi-Fi access point will limit with the number of devices that you could connect, irrespective of the normal Wi-Fi and so on. Now think about an organization, educational organization. You can have this small 5G tower, and all the students can get the SIM card, and you get free network, right? Free network, right? So that's the plus point of 5G. And lot of patents are upcoming ones, and it is also predicted that there will be a higher economic impact by 2035. So this shows that sensor nodes or networks can have a, a bigger importance in the near future, right? So let us, all these are some of the statistics which I want to show that we are moving ahead. India is not yet, but by this year or next year, we will be almost reaching this position, because our population is very high. We all agree on that. So what is the real objective behind this? It has three goals. Okay, high speed, machine to machine communication, low latency. These are the three major goals of 5G. And if you compare the other technologies, of course, we majority of you would have crossed 1G, but the young generation would have started with 3G, right? Of course, 1G, some people would have crossed or experienced that with 2.4 kbps, right? And it is analog communication. Whereas 2G, it had digital communication, but it was not focusing on data assets, right? Data was not there. Only SMS, MMS, these kind of things, but it was using mobile towers, right? That is the concept here. So mobile towers were used, some infrastructure relating to the cellular network, right? Cellular network was used. If you think about 3G, which nowadays also people use in some places, right? Yeah, somewhere in between you can notice like Edge and then H plus and so on will fall under this type, right? And you can experience almost like 2 Mbps speed here. 4G is nowadays very popular in many cities. We have to thank BSNL as well as Reliance, right? So they took a major step in India to bring 4G, especially during COVID period. COVID also brought this no plus point for driving the technology far ahead during this period. And then no, because of all this COVID only, they started I mean, realizing that this should keep growing, and the importance of this boosted like anything, right? So 5G with very high speed. Let us see what is this 5G going to do, right? So if you see 5G services, one among first service, what I have told is very high speed that we can observe there, and second one is low latency. This means no, you can think about some automotive vehicles, right? Automotive vehicles or in social good application, one among is no reducing this traffic or reducing accidents in road safety kind of thing, right? So you can imagine that no, someone is braking and immediately you should get notification, or immediately the surrounding information, surrounding vehicles should get notified, and this communication should be very very low, right? The decision should be fast. Edge intelligence should perform that, and the communication should happen, right? So end to end communication delay is very very less here. So you can see here Siemens is very well working on this domain, and recently also Siemens has announced there is a call for a PhD program. So if someone is interested, you could apply. It is more specific towards these topics. And you can see what is the difference in 5G. 1 millisecond, it's okay, right? If you break in a, you go, let us think about automated vehicle. Your no algorithm should execute somewhat faster, so edge intelligence should perform with some computational unit, and immediately it is the actuator is doing something, right? Actuator is saying that now you need to break the pedal, right? So this action, right, and the communication between the edge device and the real mechatronic device should take only 1 millisecond if it is 5G. So it's very very good for automotive devices, and 6G is far beyond this, right? So it is like near almost real time, right? So 5G is having very low latency, and spectrum wise, if you see, it is having a broad communication, right? Like if you focus on one building or one one university, then you can think about high band, right? Which means the fundamental formula, like the more speed you go, it will not reach long distance, right? So 5G with high band with high speed, you can think about in this category, whereas low band, which will reach a little longer distance. So this means it can even cover someone who is having 2G, right? Some rural places you have gone, you don't have such a you should not suffer from connectivity issues. Therefore, 5G has kept it as per the technology itself. They have kept in 3 bands: low band, mid band, and high band, so that low band will support in such locations, and the high band will support in the locations where you need very high speed with converged situations. So this is how you can observe that false 5G is something where you realize in low band, right? You can see like the frequency is also like 600 to 850 megahertz, and the speed also you see only megabit per second. But think about a true 5G, which means the high band. In high band, you are expecting uh, 10 gigabit per second, right? So it is almost equivalent to Wi-Fi 6, right? Wi-Fi 6, but Wi-Fi 6 has limitation in connectivity, number of devices connectivity, and coverage also, there is issue. But this 5G, true 5G can reach that much distance, and they call it as millimeter wave spectrum. So this is the pictorial representation of how high band waves looks like. It cannot reach or it cannot cross the building, but mid wave can cross relatively small buildings, but low band waves can continue traveling long distances. So the 5G is designed in that fashion, and it has massive multiple input output support. Antenna wise also, they have a lot of things to do, and beamforming concept is there. So you can notice here a conventional antenna, how it transfers, not send the signals, right? It is omnidirectional, it is sending. But here the beams are focused, it is just sending to that particular device. So because of this, obviously the energy consumption will be less, and the utility will also be very high. And in that line, 5G technology also provides this slicing concept, network slicing. They call it as network slicing. This means you can design the 5G such a way that the entire network could be sliced, prepared, prepared exclusively for some applications, separate applications. So think about farming kind of application. You can design you can create the network, you can sector the network for that particular purpose alone. So fundamentally, it is based on software-defined networking and network function virtualization concept for slicing. And you can simply create network slices for exclusively for broadband, exclusively for machine-to-machine communication. So separately for separate applications, like for example, vehicle-to-vehicle communications, you can do a separate network slice. So like this, so you can do lot more uh, features using this 5G. But simply speaking, no, if you have the license, if you already got license, you have to get license. That is one challenge here in 5G, right? As like Wi-Fi, you cannot simply purchase and you cannot use it. Okay, you need to get license, because you are going to create a private cellular tower, right? You can create a private cellular tower. So this means, no, in an organization, you will have your own 5G. Right. So in that case, you have to get license, because it should protect the privacy of certain people and so on. So such kinds of things you will sign and you will do it. So in this setup, right, if you, there are so many providers, as I told you earlier, Amazon is providing, Google is providing, and so on. So you just collect them and you can set it up, and within 2-3 minutes, all the devices can get connected, right? Machines can talk to another machine, right? Fridge can talk to the washing machine. In the educational organization, the projector can talk to the teacher, right? A camera, attendance taking camera, can talk to the teacher, right? And it can send the data directly to cloud, or it can filter it with some edge intelligence algorithms and so on. So ultimately, smart intelligence is very curious, and 6G is far beyond of what we are going to discuss, right? There are so many good research directions which you can see here. You can design a better application. You can focus more towards creating such IoT systems, a good IoT systems, and you can study the performance of them. You can develop some machine-to-machine communication related applications, or machine-to-machine communications by comparing different protocols that are existing for IoT systems. So these are some of the research directions that people currently work on. So before I wind up my talk, let me discuss few things about some of the announcements. Basically, like at IIIT Kottayam, we have 2 incubation centers. We provide some funds for best business ideas. Like MSME, we can provide 15 lakhs, and AIC IIIT Kottayam is another incubation center where the academic organizations can become nodal centers, and they can also get the ideas and funded till 50 lakhs. Other collaborations, of course, all are invited for collaborations, and I recommend you to read this book if possible. And yeah, thank you for listening to my talk, and let me once again thank Dr. Shajulin sir for this opportunity, as well as Dr. Yoga Priya, the conference chair of this program. Thank you.
Thank you, sir. Would like to acknowledge our gratitude to Dr. Shajulin Benedict, sir, for exposing his theory of IoT communication protocols and social applications. We are all inspired by your great words. Thank you, sir. Finally, I would like to take this opportunity to place on record a hearty thanks to one and all present here. In the end, I would again like to thank the eminent speaker, respected delegates, technical committee members, faculties, head of the departments, students, and participants. Thank you again for making this event successful. Thank you, everyone. Today we are having 3 parallel sessions. Here session 1, parallel session 1 will continue. I'll hand over this session to our session chair, Dr. Vijay sir. Over to you, sir.
Yes, madam. Thank you. So welcome to the 3rd International Conference of